Good morning, everyone. Welcome to the Bio-Based Transition Indicators Framework webinar. My name is Maria Cámara, and I am the Communication and Dissemination Manager of the BioRadar Project. And today I will be moderating the session. This webinar is organized within the BioRadar Project, which is supported by the Circular Bio-Based Europe Joint Undertaking and by the European Union. The BioRadar Project is developing tools and frameworks to better assess and guide the bio-based transition across environmental, social, economic, and security dimensions. First of all, I would like to say thank you to our speakers for joining us today and also to the people that are online. We have a packed agenda with expert speakers from our consortium and sister projects. So I will share my screen now to show you the agenda for today. Can you see my screen? Okay, so first of all, we'll have a brief introduction to the BioRadar project by our project coordinator, Emad Yakmai. Then we will dive into the BTI framework with Matteo Macanti from NTT. And afterwards, Hazel Iglesias from Setema will also present the work done about the circularity indicators for the use cases in BioRadar project. Afterwards, Pujan Timisina, Isai Gonzalez, and also David Nettleton will present one of the BioRadar digital tools that integrates sustainability, circular and circularity indicators for the bio-based industry. After these presentations, we have a related project that is joining us today, which is the ESCIB project. So Dominic Roots, the project coordinator, will give us an overview of the project. And later on, Christian Perez from University of Ghent will present about the work done within the circularity assessment methodology for high-TRL bio-based product systems. So that is the agenda. Okay, so during the presentations, you can leave your questions in the chat so the speakers can answer them afterwards. Right now, I would like to invite Emad Yakmai, BioRadar Project Coordinator, to officially open the webinar and give us an overview of the project. Emad, whenever you want, you can share your screen.
Yes, hello everyone. I share my screen. Can you see my screen?
Yes, I think so.
Yes? Okay. Oh, yes, it appears. Okay. Hello, everyone. My name is Emad from Yakma. We are coordinator of BioRadar. We are a company based in Netherlands. And then my plan is to go to very briefly talk about what is BioRadar, what journey we started, and then where we are basically leading at the moment, and talk a little bit about bio-based system transition indicators, which we call it by BTI framework, which is, I think, the name of this workshop. For who we are in the BioRadar, we are consisting of the one university, two research organization, and three SME, and one standardization. We have UNI as a standardization body from Italy. We have Iris, OS, and Iris and OS as SMEs, and we have Setema and NTT. NIA of Iris and us as a SMEs, and Setema and next NTT as a research technology organization, and Hamburg University as a university. We get together in order to work on developing BTI framework to monitor and assess environmental sustainability and circularity of bio-based products within three sectors, particularly as a use cases: textile, packaging, and fertilizer. What the main things at the moment, I think, for this workshop is also to know which elements of the BTI framework that basically we worked on and which elements that we will further work later on. So the BTI framework is the idea is to have covering the sustainability and circularity aspects in a broader sense, both at the environmental, circularity, economic, and social aspects. And then they have a different type of users to be used, the platform or the different aspects of the BTI framework, and also different indicator level that we have. So, in principle, we looked at the environmental impact, risk, and cost related to that through LCA, LCC, and EcoCost. We also do the monitoring purposes for bio-based systems. So this is a basically good picture of what we do under the BTI framework. It's not only the framework itself, but then it has both different aspects of the quantitative and qualitative aspects that is going to be added. So we look at the social impact implications, social LCA. We do the benchmarking, which later on I think Iris will show the digital screening tool that basically do the benchmarking against indicators of circularity, social LCA in the long run, environmental sustainability, and so on. And then we also do have some best practices within the three sectors that we're working. And we also look at the regulatory framework of monitoring them in order to be able to self-assess against the regulatory aspects. The project is working on drafting a SEN workshop agreement for standardization to make a pre-standards later, which is going to be towards the end of the project. So in a nutshell, the demonstrator that we have, basically the cases are in textile, packaging, and chemical, and particular fertilizer. We do try to help improving these metrics and framework, both for environmental sustainability and circularity. We look at the economic aspects through LCC and EcoCost, and then social implications. But I think that is going to be discussed in more detail, each of them by NTT, Setemna, and also the digital by Iris later, so I'm not going through details of each aspect. And then is the, then we also have, we also have kind of the wrapping of everything under so-called replication facility, where we are basically showing the resources, best practices, and also dissemination and communication aspects. We do have the massive, like a MOOC, massive online courses that comes for dissemination, communication, and potentially exploitation activities. Today, I think probably we will look more at the levels of the tool, a benchmarking tool. Before that, of course, more what is indicators going to be added to the benchmarking tool, but a benchmarking tool through the lens of environmental sustainability. We do have also regulatory tracker tool, and also, as I said, we do work at the moment on drafting the pre-standards together with SEN, European Standardization, via UNI as a partners from Italy. And yeah, we do also have, I think that is common to have a community around the professionals that we have within these three sectors to be connected to also get feedback where we are. So that is who we are, and then that is the partners. I will give the floor to our colleagues from NTT and Setemna. And I do apologize in advance that I need to leave. I hope my voice was clear enough, and it was in an exhibition. So I will need to leave in a couple of minutes. So wish you a good webinar. Thank you very much.
Thank you, Matt, for setting the scene and putting the BioRadar project in context. So our next speaker is Matteo Macanti from Next Technology Textile. Matteo holds a PhD in environmental science and technology and works as a researcher and LCA analyst at NTT. He brings expertise in LCA, social LCA, and life cycle costing, with a strong background in European project on sustainability, textiles, packaging, bio-based materials, and eco-design. Today, Matteo will introduce the bio-based transition indicator framework, and he will explain how it applies to the BioRadar case study. Matteo, the floor is yours.
Thank you so much, Maria. Okay, can you see my screen?
If you can put it in full mode.
Yeah, I'm trying, but my computer is a little bit. Okay,
Yes.
now I
It's
think
perfect.
it's okay. Okay.
Yes.
Okay, thank you so much again. So, thank you for your presentation. I don't know how to. Okay, okay. So, I will talk very quickly about the next technology, Tecnotessile. That is a research center born in 1972 in Prato, in Tuscany, near Florence. We are around 30 people at the moment, and our work is concentrated on the research, development, evaluation, testing, and validation of material, different type of material, new material, bio-based material, like the one that we are working on in this project in BioRadar. In particular, we are concentrating in the textile sector, but also we work in other sector like the packaging, automotive, furniture, and building sector. We are involved, as you can see, in many European projects. And one of these offshore is BioRadar. So, only one question. You see a black box here in the
No.
higher part of the. Okay, perfect.
Well,
Only
we
me.
see you. We see you there.
Okay, perfect. Okay, so as always, when I present something about the sustainability, I like to start with the global context. So why we are talking about the sustainability? Because we are 8 billion people in our home, in our planet, and we have many problems regarding the environment and how we manage the resources and how we approach to our planet, to our home, as I said. So we have a solution to change our mode to live and to approach to the planet. But we have to change our mind. We have to change our type of thinking, and this change, the base of this change is the sustainability, so the sustainable development, and it's important to follow the theoretical approach called the life cycle thinking. So that is a way of reasoning that think about the process and the products in all the life of these products. So there are 3 pillars that are environment, society, and economy, and there are different methodologies to try to evaluate, study, and see the impact on these 3 pillars. The main most important are LCA, social LCA, and LCC, but I will talk about this and other methodology during this presentation. So regarding the BioRadar BTI framework, in this project we concentrate on the study and evaluation of many different products of 3 sectors, so bio-based products. The 3 sectors are textile, packaging, and fertilizer, also said by Emad. And we try to study the 3 pillars of the sustainability with the use of different methodology. For the study of the environment, we use life cycle assessment, the indirect land use change, ILUC, and the image evaluation. I will talk about this in the next slides. For the social part, we applied a social life cycle assessment in 2 different ways. And for the economy part, we applied a simplified environmental life cycle costing and also an eco-cost evaluation in order to try to better evaluate and better understand the impact of these of the products of these 3 sectors, also respect the standard, the fossil one products. So regarding the 3 main methodology, I will not talk about a lot about this because are the main known. But we evaluate the environment through the life cycle assessment. That is a standardized methodology based on two ISO standard, the 14040 and 14044, that evaluate the environmental impacts of products and processes throughout the entire life cycle of this process. We apply the life cycle costing, also the eco cost. The first one, the LCC, evaluates the total life cycle cost of a product, while the eco costs try to translate the environmental burdens into a single monetary indicator of sustainability in order to try to appreciate also the cost of the environmental impact. Regarding the social LCA, this permits to evaluate the social and socioeconomic aspects of products and also their positive and negative impacts throughout the entire life cycle. Here you can see the system boundaries that we applied to all the products in order to try to have the same boundaries for all the methodology that we use. Regarding the social LCA, little focus. So we apply this methodology in two ways. The first one is to collecting information directly from stakeholders involved in the project, in the sectors of the project. So we disseminate dedicated questionnaire to companies and workers, but we also add a study, a more analytical study of all the supply chain of the products and the processes through the application and through the modeling the process with the social hotspot database, the SCHDB, that is a specific database for the social LCA integrated in the CIMAPRO software. So regarding the indirect land use change, I want to explain a little bit what this is because it's not very common, and but I think it's very important when we are studying bio-based products. According to the IPCC, the land use change can be divided in two different types. So there is the direct land use change and also the indirect land use change. Which is the differences? We can talk about this with this figure. We can have two types of scenario. The first one is the direct land use change, where this is the initial situation. So we have cropland and natural land. In the direct land use change, we have the cropland that remain cropland, but we have the natural land that is covered to a new cropland in order to have the raw material, so the bio-based material for our bio-based products. That is the simplest scenarios because we directly know which is the change of the land use. The scenario number two is the indirect land use change, where the cropland is converted to the target products that we want. So for example, I don't know, the corn for our bio-based production, but we have indirectly a change of natural land because humanity needs cropland that are covered by this production. So it's a little bit more difficult because it's a planetary change of land use, but it's very important because a variation in the land use we can have also a variation in the carbon balance. So we can enrich the emission of CO2 in the atmosphere. I want to also spend two words regarding another methodology that is the image evaluation. It's a not common and not known methodology, but I think it's very important to disseminate this type of methodology, in particular when we talk about bio-based material. Energy is an environmental accounting method that estimates the effort required by nature to concentrate the primary energy that feeds all the processes that take place in the biosphere. So energy, that spell is with the M, is defined as the solar energy, the total solar energy required directly or indirectly to produce service or products. So in this way, we can understand better which is the real effort of the nature, because we can evaluate a more wide boundaries respect, for example, the LCA. We concentrate on two different indicators. The one is the main important, the most famous indicator of this methodology, that is the unit energy value, that is the sum of the direct and indirect solar energy that is stored in all the inputs that feed the processes, whatever natural or anthropogenic inputs. And also, in particular, in this type of study performed for BioRadar, it's important the renewability rate that shows how much a system relies on renewable sources that are not the traditional idea of renewable sources, so are not the solar panel, for example, but are the inputs that derive directly from the nature. So, for example, the inputs from solar, from sun, wind, rain, to feed the cultivation. If you're interested of these images, this figure derived from a comic that is Solar, born to the scope to disseminate and explain this methodology that is very interesting but not enough known. I will talk a little bit about the BioRadar data collection framework. That is a very important part of our work, because we try to not spread our time not in the collection of data, because it's a very crucial part of the data collection, and we try to optimize this part of the work also in order to try to apply this framework in the future, for example, for companies that usually they don't have time to collect data. We start with the data collection, the traditional life cycle inventory for the LCA. We use this data collection with this LCA also for the life cycle costing evaluation, and also for the social hotspot database, because with some modification of the data, and adding also some input for some external input from literature, for example, or from international database for the economic part. And for the image evaluation, again, we use the LCA input-output data. We add information from literature for the unit image value, and in order to obtain the image results. And again, for the e-look, we use part of the information that we collected for the life cycle inventory. We use a specific emission factor from the European Commission in order to evaluate the indirect land use change. Okay, we go a little bit quick because I want to present only some main results that we obtain from this evaluation. Please, Maria, let me know if I don't have time for this part.
You're fine. You have 10 minutes.
10 minutes. Oh, okay.
Yes.
Okay. Perfect. So, okay. I present the main results that we obtain from this evaluation. The first part is regarding the environmental part of our evaluation. So first important things is that the triangulation that we applied, so the use of three methodology for the evaluation of the environmental part, so LCA, ELUC, and energy, is not a waste of time, but it's a very important methods, because we have the opportunity to yield more consistent decision-ready signal that any single method can do. So we saw that probably is not probably it's quite common, these results, but it's important. So bio-based is not automatically don't mean automatically sustainable. It's important to treat each product, each case as a case-by-case process. It's important to focus on some part of the processes, in particular the energy mix, some process chemicals that sometimes can modify, can enrich the impacts of the project, of the processes. And also important to think about the end of life of the products. Some important aspects, so it's important to reduce the electricity and the heat demand, optimize or replace some critical chemicals, reagents, and also important to explore the co-products valorization. In particular, this is important, we saw that this is important for the fertilizer products. What we understand from the ELUC, for example, we saw that the pasture-intensive products like wool, for example, can increase a lot the GHG impacts. Regarding the packaging, the bio-based the bio-based packaging, the impact deriving from the land use is can differ widely. So we have to in the future probably to perform a better and more specific evaluation of this part in order to better understand the differences of the different processes. And in the case of fertilizer, we can have in some cases a net benefit. So we have a carbon in the carbon balance, we have a carbon uptake instead of a carbon emission in the atmosphere. From the energy, we understand that it's important to improve the renewable percentage in order to switch, in order to reduce because it's important to reduce the use of fossil-based input. So it's important to reduce, for example, to improve, for example, the renewable electricity. It's important to close the material loops and also use the low impact feedstock. It's important to continue the evaluation of these processes during the time, so the track the UEV of these products in order to see how is the trend in the time of these impacts. Regarding the sustainability, the social sustainability, from the survey, we saw that the decent work fortunately is largely ensured. So we have a good answer regarding that most of the workers have formal contracts, permanent job, and social benefits. But we have also, as you can see, our survey are concentrating in some countries of the Europe, so it's not a global vision of the value chain of the products. But there are some gaps also in these countries. So there are, for example, unpaid overtime, insufficient wages, and few companies have gender plans, working representation, or community engagement initiatives. In particular, we saw that the transparency is a key weak point. As you can see, just 30% of the companies have published the sustainability reports. And with the evaluation of the HDB, so with a more wide evaluation of the production chain of the products, we saw, for example, that there are labor risks, rights and governance risk, in particular for wool, viscose, and wood vinegar fertilizer. It's moderate, for example, for compost, and low for hemp and algal-based solution. And these reflect the supply chain geography, because, for example, for wool and viscose, the supply chain is more wide. Some products, some raw material derived from countries in the world that don't have don't hard there are not so important attention to the labor. So it's important to better study these supply chain, and also to try to modify the supply chain and modify the change the country from where we obtain the input, the raw material. In conclusion, the last part is the economic sustainability. So we see that costs are sector specific, but also energy and labor driven. In particular, the chemicals is a very critical part for each of these sectors. Fertilizer economics are highly sensitive to system design. In particular, for example, for compost, we saw that this is cost effective when there is the biogas valorization. And for algae, it's very important the costs of the wastewater. Regarding packaging textile, LCC shows that reducing the material and energy intensity, these directly affect the cost. Regarding the eco cost, these methodologies show that the externality costs, so for example, the toxicity and the greenhouse gases, are aligned with the same hotspot that we saw with the LCA, also because are directly depending with the LCA results, this methodology. And okay, it's very important the fluctuation in the feedstock costs and obviously the energy prices. So in conclusion, we saw that there are no single solution that fits for all the bio-based products. There are some aspects, some inputs that are very important, and it's important to concentrate the effort and the evaluation of this part. So the energy mix, for example, the process chemistry, and the land use and governance. The hotspots are clear, it's clear which are the main hotspots on which we have to concentrate. We also saw that the integration of these different methodology is very important. We hope, because we have the opportunity to have a better, clear, better, wide and true picture of the reality of the impact of these processes and products. We have many solutions are already here. So we have to switch to renewable energy, concentrate of some critical reagents, as I said, concentrate also of the circular end of life, and also valorize, as I said, the co-products and social and develop the social policies. In general, we can say that bio-based products are better with respect to the fossil one, but it's very important to evaluate, to study, and to concentrate on these some critical aspects and these hotspots that we see in our evaluation. So thank you so much for your attention. And then if you will have some question during the webinar or also in the next day, you can also write to me by email. Thank you so much.
Thank you, Matteo. I actually had a few questions, but I think you answered them all in your presentation. It was very clear and comprehensive. So as we are a bit tight on the schedule, we are moving on to Hasler Iglesias from Setema. Hasler is a chemical engineer and economics PhD candidate with expertise in circular economy, corporate sustainability, and innovation. Today, Hasler will share with us the circularity indicators developed within BioRadar and their applications in the textile, packaging, and fertilizer sectors. So Hasler, whenever you want, you can start.
Many thanks, and also for everybody who's connected and listening. So yeah, I will proceed then to explain what we did in BioRadar to address circularity. Can you see my screen? Yeah, perfect. Thank you. Okay, well, so first of all, I wanted to present Setema. Setema is a technology center based in southeast Spain, in Cartagena. And our goal is basically to help businesses to be more competitive in the areas of environment and energy. So we work from all kinds of companies, both in Spain and in Europe, regarding things like waste management, energy efficiency, renewable energies, production of bio-based materials, and even circularity plans and strategies for companies. And many of other things, including European projects such as this one. So regarding circularity, we started from the point that many times circularity is taken for granted when talking about bio-based products. People think, okay, is it bio-based? It means it's automatically circular because I'm using renewable materials and so on. The truth is that it's not always the case. And we cannot assume or take for granted the circularity of even bio-based products, but we have to find some ways to measure it. So to begin into finding how to measure it, we looked at what has been done in the scientific community so far. So we conducted a systematic literature review, which is already into peer review. So we hope you can have it available in a couple of months, hopefully. And we looked specifically for indicators of circular economy that were being used in bio-based fertilizers, packaging, and textiles. So we found, as you can see in the left side, that most of the indicators were actually for general purpose. So you can use it for measure the circularity of a fertilizer or of a mobile phone or of a t-shirt. So they were not specific. And this has the trade-off of not accounting for what matters in most of the case. So you may be measuring something that it's okay, but it's not the core of the circularity of your product. And then the fertilizers and packaging were given more attention in the previous developments. And lastly, textiles, which was actually interesting because textile is one of the key sectors in sustainability. It's always present in discussions, in policies, in news. And it was kind of surprising that until that time, only 7% of the all indicators for bio-based products were for textiles. On the other hand, we looked at, well, what was people measuring when talking about circularity? And most of them were measuring the recycling stages. So we have reduced circularity on recycling, and the truth is there is much more about circularity than recycling. For example, another interesting thing is the prolongation, the extension of the lifetime of products, which was the second most measured thing, together with efficiency. So circularity is not only recycling, but also prolonging the time any product is in use. And all the way down, you see also economic inputs such as prices for revenues, the end-of-life processes, also widely used indicators such as the Ellen MacArthur Foundation Material Circularity Indicator, or the LCA, as my colleague Mateo explained, were used as circularity indicators. The MCI is actually a circularity indicator, but LCA, there is a discussion whether it is a circularity indicator or not. I would say it's rather a sustainability indicator. It doesn't tell you how circular something is. It tells you rather how much impact it has on environment. So at the end, both things goes hand in hand. But yeah, about 50% of the indicators we found were focusing only on LCA and saying they were measuring circularity. So at the end, we found lots of dispersion, lots of concepts for circular economy, different people considering circular in a different way and measuring different things. So this was like the first picture we had of where were we going to get in. Here kind of a summary of what I already said. Well, the key limitation is that these indicators were not accounting for the biological cycle. They were only focused on the technical cycle of the circular economy, meaning synthetic materials, and neglecting bio-based materials, even in bio-based products, because most of these indicators were not designed for bio-based products, but rather designed for conventional products and then reapplied in the bio-based industries, which logically leaves out many of the key aspects of bio-based or circular bioeconomy. For example, fertilizers, they only focused on nutrient recovery, and that's it. They didn't measure anything else. Packaging, one of the key elements of circular packaging is that they can be reused as many times as possible. And these loops of recycling were mostly overlooked in these indicators. And the textiles, the indicators were only focusing on the fiber manufacturing stage. And when you want to speak about circularity, you can think only in one single stage. You have to consider the entire life cycle of a material or a product in order to prolong the entire life cycle, not just make more circular the manufacturing. For example, in the textile, we're seeing lots of take-back programs, even in high-scale textile brands that are trying to even repurchase their own products to reincorporate them in the circular economy loops, right? So we also found some trade-offs. For example, we had indicators that give you only a conglomerate value. It tells you a score, and that's it. And when you are comparing two values, you can say, okay, this one is more circular than the other, but you can say why, because you only have a single value. And the opposite to this is having like single variable indicators that tells you, okay, this is recycling this much, or being reused this much, or has this amount of bio-based materials, and so on and so forth. Then we also have this tension between data availability and indicator innovation. Circular economy companies are still discussing how to measure it. So if you haven't measured anything, you can't build an indicator on existing data. But if you want to have a strong indicator, it could be the case that you don't have yet the data to calculate it. So there is always this tension, like a chicken egg problem. Where do we start? Measuring something, even if we are not sure that value is going to be useful, or developing an indicator, even if you are not sure if you're going to have the data to feed it. And then always the complexity and on simplicity. You can make circular indicators as complex as you want, but we tried to strive for as simple as possible indicators with intention of them being adopted by businesses. Our focus was businesses, and in BIORADAR Project, and not producing an additional academic indicator that is useful for research, but may not be applied in the actual business sector or industry area. So after this discussion, we proposed this set of 8 indicators. One of them, I mean, 4 of them already existing. So we took them from this research and we proposed 4 new ones. And at the end, with this circularity monitoring framework, you can measure the circularity of any product with 2 indicators. With 4 indicators, sorry. The one that it's general, that you can apply it for any product and you can use it to compare between products, which is a circular index or circulability. And we complemented it with the biodegradable content. And then depending on what you're measuring, for fertilizers, you can measure the recovery of nutrients with the circularity indicator of nutrient, and also the nutrient slow release index, because we have found out that actually the key effect of fertilizers occurs after they are applied on soil. And there are the biggest environmental impacts and so on. So we wanted also not to only look at how much nitrogen is recovered from bio-waste, but also for how long does this nitrogen is released on soils and not leaked into water bodies, for example. For textile, we found this really interesting indicator, resource pressure, that I'm going to speak a little bit more about later. We complemented it with the fiber treatment. In this case, not only looking for how the fiber is manufactured, but actually all the processes it undergoes before getting to market, to make it like more soft or more appealing to consumers and so on. Then packaging, the existing one is the recycling effectiveness, which also considers how is the quality of the final product you get by recycling, how pure it is. But we coupled it with the virgin material consumption index that we are proposing, because most of the times, okay, you are recycling, let's say, cardboard, but within the cardboard recycling processes, you also consume virgin materials that you need to supply it to the recycling process. And you may say, okay, cardboard is 100% recycled, but you are not taking into account how many or how much of virgin materials you had to use to actually conduct this recycling. And these are all circularity relevant things. So this is the application. Now we're seeing what we got when we applied this set of indicators to actual products. This one is already published, and you can get to it through the QR or the DOI code. So here we applied the indicators to fertilizers. And for example, it was interesting to know how they are useful for comparing how circular are each of these options. For example, compost, which is one of the most known fertilizers, is in our sample is the least circular. Using the circular index, it's perhaps it causes well, I mean, it's still over 85% of circularity, so not bad at all. But it produces certain amount of waste in the non-compostable waste that you have to dispose at the end. In contrast with algae, that you are using the entire algae material as a fertilizer. Also, in biodegradable content, the same. I mean, obviously these are bio-based fertilizers, so most of them are 100% biodegradable content. But for example, spent matter substrate is still high. I mean, almost 93%. But the other 7% is these non-circular materials that you have to use in this manufacturing process. So yeah, for fertilizers, this was that was it. Like, you be able to compare different fertilizers, rank them even to make a decision if you want to strive for circularity, if you're deciding what to produce, what product line to prioritize with the criteria of circularity. This set of indicators is actually useful for that. For textiles, this is the resource pressure I talked about a little bit. This is also undergoing peer review, so we hope you will have it available in a short time. So this resource pressure, it's actually interesting because it's incorporating in the calculation the planetary boundaries. So here, these curves you see, the higher it is, the closer this material is to trespassing the planetary boundary. So one would aim to select a material that has a low resource pressure. And in this case, for example, it was cotton, which is a bio-based textile or bio-based fiber, the one that had the highest resource pressure because of all the processes it has to undergo. In contrast with, for example, with polyester, actually these three, polyester, wool, and hemp, there is no significant statistical difference. So we have here two groups. The resource pressure level of cotton, which is actually higher. You can see it in the normal scale, how high it is compared with the other three, which are, one could say equivalent. So wool, polyester, and hemp, regarding how close they get or how far they are to the planetary boundaries. The same happened for packaging. This one is confidential. This one is not published. It's let's say a private service we offer to a bio-based packaging material manufacturing company based here in Spain. Here, the interesting thing is that they used it, for example, to analyze scenarios of their own manufacturing process. So to decide whether it is relevant to target a 5% recovery or a 10% recovery or a 15% recovery of a key material, and see how does it impact their circularity. And for example, in this case, in all scenarios, they were still above average. So this is actually a tool to guide managerial decisions in what process to invest or what technology to apply, depending on the circularity level and how you benchmark yourself to the industry. This one, for example, it was interesting, the biodegradable or compostable content. You could say, I mean, if they are producing cardboard, how is it possible that they are scoring 0 in the biodegradable content? Well, the thing here is that we opted for tying biodegradability with it being certificated. So if you can't prove that your material is biodegradable or compostable with a recognized certification, we are not considering it's compostable. Here also to show how the industry are reaching new standards and new practices, that if you don't have a certification, you can't enter specific markets. So here as well, it may be the case that this company, their actual compostability is somewhere in between here, these averages, but as far as they don't have it certified, our framework says we can't prove it's biodegradable or compostable. And that's everything I have for you. So happy to answer some questions if you have time, or yeah, I will be here available for you, and here you have my data contact.
Thank you, Hassler. Actually, I have a question. So while doing this work, what are the challenges that you have identified regarding corporate adoption of circular economy metrics?
Yeah, I didn't hear well. What are they? What?
The challenges that you have identified regarding corporate adoption of this circular economy metrics.
Yeah, perhaps the most important one and the most common one is not having a homogenized methodology or a widely recognized methodology. So, for example, one company we talked with, they were like, okay, I can calculate those indicators. So what are they going to be useful for? Are they going to be recognized by any international organization? Are they going to be openly access to new markets? Or I mean, they are aiming at, like, let's say, high TRLs of these measurement frameworks. And we are still in the circular economy realm in a low development scale with lots of developments, but still not known consensus. So that's why it's important, for example, the work we are doing for the pre-standardization documents. So try to offer, or in this case, include our outputs of the projects into these standardized methodologies to measure circularity. So companies can be assured if they are going to make an investment of people measuring things, or if in instruments to measure things, that these measurements are going to be useful for them, not only for internal managerial purposes, which I already think it's really important to have internal data, internal measurements, and internal indicators to guide your company. But most of the cases, the companies are market oriented, right? They want to measure. I mean, if they can measure something that it's useful for themselves, but is additionally going to serve as a demonstration of what they have done, as a certification, they're more willing to do that. So I think that's the key challenge we have. Not only convincing companies to measure things, but actually giving more strength and power to these measurements in the market or in the regulation arena.
Thank you. Thank you, Hasler. Very nice presentation. Very, very clear. So up next, we have Pujan Timensina, Isai Gonzalez, and David Nettleton from IRIS that will present for the first time one of the BioRadar digital tools. This tool is designed to integrate the sustainability and circularity indicators for the bio-based industry. So Isai, Pujan, whenever you want, you can share your screen.
Thank you, Maria. Thank you, Maria Hasler. A nice presentation, Mateo. Also, thanks for the presentation. It's I have to say that it's a pleasure to collaborate with you guys because you have been doing something innovative, and then we are englobing all of your aspects here in our in the digital platform that we are developing. Okay, so before going to what we have done and within the BioRadar panorama, I would like to give you a quick explanation of my company, what we are, where we are based. So today I'm here jointly with my colleagues Isai Gonzalez and David Nettleton. So jointly with we are going to show you what we have done within BioRadar. And then we come from Iris Engineering. Iris is a small SME based in Barcelona. And then as per our core business lines, we have two different core business lines. We are manufacturers of photonics and artificial intelligence solutions. Basically, it's used for the control of industrial and production processes in real time. And besides of this core one line, we're also developer of high performance digital platforms for exploiting data with artificial intelligence and deep learning tools. So the BioRadar projects englobes second line of our business, but is also somehow related to our first lines. Okay, and besides of these two lines, we prepare proposals or Horizon Europe proposals, and also regional and national level proposals in Spain. And then we try to innovate and then to assure that our two of the business lines they improve depending on the innovation factor that is provided by Horizon Europe. So now within BioRadar, we are planning, and then rather I say we are planning because it's still the digital platform that we are going to show you right now. It's still on process. So the aim is to develop a digital monitoring tool that integrates different aspects of sustainability. So Hasler and Mateo, they had explained the more investigation part and the analysis part, and then we are digitalizing these aspects and then providing the user ability to perform bio-based comparisons, benchmarking, etc., etc. Okay. So a picture is worth 1,000 words. So rather than going in detail of what we have done, we would like to directly show you what's going on within the BioRadar platform. So Isai, if you would like to share your screen and then show the digital platform. Okay, so this is the landing page. Basically, what we are asking to the partner, to the users. I'm saying partners because right now it's open only for the partners. But then after, if you come and take the platform for after 1.5 months or 2 months, it will be open for the external users also and the stakeholders. So this is the landing page. You need to register because we are talking about data provided by the project, and also there are sections where you need to upload your own data to compare, to do whatever the analysis you'd like to do. So this is the main landing screen. It's going to be updated also. We're still working on it. But then the first requirement is all the user who would like to work or who would like to play with the platform, they need to register. So we have the common register screen and login screen. let's not go in detail about the register and login experience. So Isai, if you could proceed. Okay, so let's go to use cases. So Hasled, when he was explaining before, one of the key, let's say, bottleneck is lack of data. So normally when we are talking about circularity, sustainability, there is always this factor that we are missing data. Lack of data is the major problem, and then major bottleneck because we don't have data to compare, or we don't have data to analyze, or we don't have data to take as a reference. And then within the project, with the BIORADAR project, fortunately, we were lucky that we had partners like Tineline, NTT, and then YAGMA, and then they provided a lot of data. And for each of the data, for each of the cases, so we have 3 use cases: fertilizers, packaging, and textile. For each of the use cases, there are different products, and for different products, we have impact. Our partners, they provided us a list of impact categories, and for these impact categories, we had enough data. So what we decided is, okay, so hence we have for this project we have enough data. So why not make a baseline? The baseline in the sense that we could have a platform that enables you to generate a lot of synthetic data that's really, really, really close to the real data. That's why we have within this platform now, we have the use cases portal. Isa, if you'd like to say something about this screen.
Hello everyone, do you hear me?
Yeah.
Okay. This section basically, as Puyon was saying, is an informative section. It's basically divided in the 3 sectors that are the project focus: fertilizers, packaging, and textile. And what you can see is for each of the sectors, the different products analyzed. Okay. Inside of each of the products, what you are going to see is the 16 impact categories. Okay, which are common for all the products, and the use cases analyzed. In this case, corrugated board, folding box board, with all the measurements and the units. Okay.
And to add
basically
up,
yeah.
Yeah, and to add up, right now you're seeing only the LCA data, because that's the core module which integrates all the 16 life cycle assessment indicators. But then our aim is not to work only with the LCA data, but then for each of the product and each of the use cases, you will also be able to see the social LCA, the circularity index, etc., etc. Okay, so it's still a work in progress, and then in a couple of months you will be able to see in the same scenario also data for social LCA, circularity, etc., etc. Isai.
Okay. Yeah, we can jump to synthetic data if you want to say something about synthetic data.
Okay. And then, yeah, so as I was giving in my introduction, one of the major, so we have been from IRIS and within different European projects and also client-based projects, we are involved in a lot of projects where we need to analyze and we need to provide a benchmarking, or we need to analyze basically on the life cycle data. We have to do life cycle assessments. And in this scenario, we always had this problem of lack of data. Lack of data is not only lack of data, is because of the confidentiality, because when we are talking about data, most of the time it's the end user industries, they are providing their internal data, and then it's the confidentiality issue or whatever is the issue, we don't have that much of data. Okay, so in this case, within the BioRadar framework, we decided, okay, so let's design this module where with maybe, let's say, only 3 or 4 sets or 5 sets of data, you could generate so many synthetic data set, and they are really close to the real data that user in future they could just generate synthetic data and then use this data as real data. Okay, and that's the aim of the synthetic data module. So Isai?
Okay. this section, basically the functionality is, again, we have the 3 different sectors with the different use cases. Okay, and how we proceed to generate the synthetic data is selecting use cases. The minimum use cases that you need to select is 5. So here, as you can see, you have the simulations and the observations. Those parameters are the parameters that modify the algorithms that feed this functionality, which are quite complex statistical algorithms. So if we generate, for example, 100 observations for 5 simulators and click on generate synthetic data, we need to wait some seconds. Here we have some information about the measurements that we've established, and the result that we have in this section is a document downloaded in the computer. Oh, sorry. Okay, with all the simulated data, which, as Pujan was saying, is quite similar to the real world data. Okay, so this information is valid to feed other sections and provide more information about the different measurements.
Yeah, so what we are doing here, just to globalize, it's now we're working on the project cases. So we had to select, in order to generate realistic data, realistic synthetic data, you need 5 cases. Okay, so that's why we're selecting 5 cases. And then out of these 5 cases, we have asked the program, okay, how many data would you like to have? And we said 100 observations is the number of data that you'll be receiving. And then simulation means how many iterations we would like to ask the platform to do. So let's say the first iteration is maybe it's not that close to the real scenario. We're giving 5 because with a lot of simulations and a lot of analysis, we found that the optimal after 5th simulation, the data tends to be really similar to the real data. Okay. The thing is, if you could do 100 simulations, but then it will take you more. The time is more. You could take it may take you 1 hour or even more. The realistic scenario is 100, like 5 simulations and then 100 data, and then you could also, it's not only 100, you could provide 1,000. You could ask as much of data you like to. And in future, our aim is now you are using cases of BIORADAR, use data provided by the partners. But then maybe the user could upload their own 5 cases and then say, okay, so out of these 5 cases, please generate me other synthetic data set that I would like to use to compare my new bio-based product or any other existing product, and I would like to compare. Okay, so that's the aim.
Yeah, can I just add, Pujan? Yeah, when we say the data, the synthetic data is similar to the real data, we mean statistically. And so what these algorithms, we've got some sophisticated statistical algorithms in the back end. And the idea is that the correlations are similar. So the cross correlations between the variables are similar. That is one criteria to generate the synthetic data. And also the max min standard deviation. So like the distribution of each of the variables is similar to the real data. So here we just saw an example of selecting 5 cases as the seed real data to generate the synthetic. And really, maybe that's not a lot of real data. You know, the more real data you've got, then the better the synthetic data is going to be. So maybe if we're going to generate synthetic data for fertilizer, one option would be to select all of the fertilizer cases that we've got, which are like 20, yeah, something like that, and use those to generate the synthetic data. Yeah.
Yeah, thanks, David. Thanks. Yeah, it makes sense. Yeah, basically, as much the cases you have, as much the reference you have, the program is more accurate and realistic. And yeah, so Isai, let's proceed.
Okay, the next section is the self-assessment tool.
Okay, so one of the module that we developed within the project is the synthetic data set. You have already seen it. And then another module that we have and which we believe is more interesting to the users and the stakeholder is a self-assessment tool. What does mean by self-assessment tool? So let's say I'm an industry or I'm a academic partner, and then I would like to compare my, let's say I have just done some analysis and I have come up with a new bio-based product. And then I'd like to see if the bio-based product I have developed, whose data, which I'm not sure if it could be considered first as bio-based, or it has similar characteristics as one of the product that I have already developed previously. So you within the self-assessment tool module, you have the possibility to compare your previous data with your new product data, or even you could use right now the screen you are seeing is compare basically what we have how we have started is comparing the data of the project of BIORADAR project among each other. And then we said, okay, let's give one more functionality to the user, which is compare their data with project's data. And then the third functionality is compare their historical data with their new data. ESCIB.
Yeah, basically the functionality is selecting one of the sectors, then select a product, select a case. Okay, and what you are going to see is the baseline use case and the closest match, second closest match, and third closest match to that baseline use case. Okay, for the 16 values.
16 indicators. This is for LCA. Remember, this is for we are always the core of the platform right now is the LCA data, and then the 16 indicators for LCA. So in this case, for case 4, the most closest match, our reference case is case 4. The most closest is case 1, and then is case 3 and case 2, and so on. Yeah, score charts.
Okay, score charts, it's another way to visualize the information in a bar chart. So again, what you need to select is the one of the measurements, and you will see the different comparisons.
Yeah, it gives you the functionality of comparing one indicator with other indicators. Not only the first screen you saw was for the global score, a comparison of global score. But besides of this, you could also check indicator by indicator. So, for example, Hasler was explaining about I think air pressure. The pressure should if it's more exponential, then it's close to out of the space. So maybe you could compare that indicator here and then see, okay, so where are we and how it's where my product is located. Okay, decide.
And the other functionality, main functionality, is the self-assessment tool, Jan?
Yeah, so this is what I was explaining before. So within the self-assessment, what you have is you could analyze with platforms use cases. So I could analyze the use cases that we saw before, but then I could also analyze with my own files. So I could upload the file and then I could see, okay, let me compare my previous data with my new data. And also I have the third functionality, which is analyze with platform use case and some of your files. Compare data from the platform, we mean the project data, with my own data. And then finally is like analyze with platform use cases and adding form data. That's a model that's we are still working, and then it will be ready in a couple of months. So in order to be able to upload data, we have this XML file repository, ESCIB.
Okay, as Pujan was saying, to feed this section, we have a file repository where we are going to be able to upload our own information. To do that, we provide a template with an structured format to upload information. And also you can upload the synthetic data generated in the project, okay? So the information is based on the 3 different sectors. It needs to be established when you upload the information. And if I go to, for example, analyze with some of your files, I'm going to see the list of the files related with the sector. And for example, this one is the synthetic data generated previously. I uploaded before the meeting. And if I select the information, I can execute the clustering for this information. Okay, so this is 100 of use cases synthetically generated. And if I click on clustering, it's going to take a while. It shows us all the information with the distribution in the two axes. So David, if you want to go deeper with the explanation of this area,
Yeah, well,
please
here
go
we
ahead.
can see that the clustering, this is like a standard k-means clustering, yeah, and it's generated 4 clusters. So it's grouped the use cases into 4 groups, similar groups by similarity. And so this is a 2-dimensional representation, which are the principal components. We've used the top 2 principal components to do the display in 2 dimensions. And so you can clearly see that cluster 2 on the left is distinguished with the light brown squares, is distinguished from the cluster 0, which is on the right, which are the triangles. And so in order to interpret this and give it meaning for the impact factors, because this is the LCA data, then we have the decision tree, and this actually uses the cluster IDs as labels to do a supervised learning and builds a decision tree. And so this decision tree actually helps explain the clustering. So if we go from the top down, we see that the top criteria in the decision tree is amplification terrestrial less than or equal to 0.045. And so if that is true, we drop down to the left 1 level and we reach the next node of the decision tree, which is acidification less than or equal to minus 0.002. If that is true, we drop down to the bottom level of the decision tree and we get the cluster ID. So cluster equal to 2. So what does this mean? Well, it's actually telling us that the use cases in cluster 2 comply with 2 criteria: entrification terrestrial less than or equal to 0.045 and acidification less than or equal to 0.002. So it's describing the cluster members, yeah? And the same for the other clusters. So cluster 1 is, again, entrification terrestrial less than or equal to 0.05, drops down to the next level, which is acidification less than or equal to 0.002. But in this case, it's false. And so if it's false, it drops to the right instead of the left, and it reaches cluster 1. And so again, we're describing the differences between cluster 2 and cluster 1 is based on the acidification. And then the same following the same procedure for cluster 3 and cluster 0. Okay,
Thanks,
thank
David.
you.
Yeah, so what this functionality helps to the end users and to the users by itself is, let's say they could give their own criteria. So for example, for a company, they could say, okay, I would like to see all the products whose acidification level is it's lower than 0.002. Okay, so in this case, they could come here and then say, okay, so what are with the data that we have generated or with the data I have uploaded, which are the cases where the acidification is lower than this, and then they could go to cluster 2 or cluster 1. And then if they want something that's higher than 0.0021, then they could go to cluster 0 or cluster 3. Okay, so this is some functionality that we are helping the users to interpret their data and then to analyze the whole process. Isai.
From my side is all the functionalities right,
Yeah.
and this is the current application that we have.
And then to reiterate, the first explanation that I gave is still a platform on progress. Okay, so you see, we're still working on it. If you in couple of months, you will see even the user experience. Now we only have the modules, but then we're making it more agile, more user friendly. We're still working on it. Besides of all the screens that we saw today is only for LCA. But then the social LCA and circularity indexes will also be integrated here. So that's our next goal till end of the project. And thanks, Maria. If you have any questions, or if the users, if the listeners they have any question, then please feel free to ask.
Thank you, Pooja, Nisai, and David. The platform looks really good. I can't wait to see the full development in a couple months, 3-4 months, and I'm sure the end users or the people interested in measuring sustainability and circularity will be very interested in learning more about this. We actually don't really have time for questions because we're running a bit late. So I will jump to our related project, ESCIB, who is joining us today. We have 2 presentations from this project. And the first one is presented by Dominic Roots. He's the head of the Bioenergy and Bioeconomy unit, WIP Renewable Energies in Germany, and he's the ESCIB project coordinator. Dominic will give us an overview of the project. So, Dominic, the floor is yours.
Yeah, many thanks. I hope you hear me and you see the full screen.
Yes.
Okay, very good. Many thanks for inviting us to give a short presentation about the project here. And first of all, congrats to all your work you're doing. I think there's a lot of similarities, but there's also some aspects that are different in the 2 projects. And well, as usual, the more you dive into the topic, the more questions you have. So that's also normal. So I didn't understand everything you were presenting, but that's very clear as the topic is very complex. And we are trying, of course, also to provide our input to the question whether bio-based products are performing better or not so good in comparison to, for example, fossil-based products. So just a bit of an overview on the project. So we are approaching the middle of the project. It's a 4 years project, so nearly 2 years done, and we have 12 partners that you can see here, consisting of well-known universities. Especially Ghent University and Utrecht University are working on the methodologies for environmental impacts and for circularity, but also supported by the other partners. And then we have 5 industrial partners. You were mentioning the lack of data. So with the collaboration of the industrial partners, we hope that we get some of the data, and we also ask them to verify our methodologies or to give us some feedback on what we are doing in the project. Just a bit of some pictures. So that's the consortium. We have visited Grown Bio, which is one of the industrial partners, and as you can see in the next slide here, we were doing also some activities. So basically, it's about a straw that is mixed with some mycelium, so that in the end, kind of mushroom is grown, and we put this into some forms, yeah. And then you have, for example, packaging material. So, and the question is, of course, is that really better or not so good in terms of the impacts in comparison to other materials? So the main objective of our project is to support the sustainability of bio-based economy in Europe overall. We will develop, or we are in the process of developing assessment methodologies, and this at various technology readiness levels. So products that are on the market already, but also on very low TRL levels. We have the involvement of these industry partners, and we would like to also give orientations for further research and innovation programs, such as, for example, Horizon Europe or the next programs that are coming up. We have a few specific objectives. The first one is the identification of best practice industrial bio-based systems. So making an assessment on what is there, what are the main uses. The second one is to develop the dynamic methods for assessing the environmental sustainability. Of course, like the issue of land use management, land use change, indirect land use, that's very critical here, and that is also addressed. The next one is the circularity assessment methods, and the fourth one, we try to bring together somehow these methodologies in order to give guidelines in the end for environmental sustainability and circularity, also for low TRL bio-based systems. The work with the industry I mentioned already, also that we try to give finally some recommendations to the policy work, and as in every project, the dissemination of the project work and also results, of course. What we are trying to do, I mean, a lot of work has been done already in other projects, in other research, but we try to address some of the gaps that occurred so far on a number of unresolved issues for LCA for bio-based system. For example, we would like to contribute to the questions of indirect land use changes, on land use induced soil quality changes, biodiversity loss, water quality depletion. Also, a core focus of our project is, of course, on carbon flows, on dynamic carbon flows. So in terms of the time when the products are used, when the materials or the biomass is grown. Measurements on circularity performance, and as mentioned, trying to contribute to the advancement of methodologies for how to tackle the low TRL products or innovations at an early stage of the development. And don't be afraid, but this is the overall, let's say, concept of our project. So first, also the first work packages are kind of a scoping, so to see what is there in terms of the products, but also the indicators, methodologies, and then we try to, or we are currently working on the methodologies for high-TRL. I hope that you just a second. I hope that you see it. So high-TRL methodologies, but also low-TRL methodologies. And here for environmental sustainability, but also on circularity. And for each of them, we have different sub tasks, so to say. We would like to combine those two together to see how the different aspects can be brought together in order to test and evaluate them also with our industrial partners, and in the end to give a contribution to the implementation, for example, for standardization bodies or certification bodies, but also for R&D directions or policy making. Well, and this is also how it is reflected in our work package structure. So the work package 2, that's more or less the starting work package, the identification of bio-based systems and benchmark scenarios. Then we have the core work package on the environmental assessment methods here in work package 3, and the fourth one on circularity. We try to bring them together and then come up with some recommendations. And all of this, we are focusing also on packaging materials and textiles, not on fertilizers, but on chemicals and on building materials. So that's our industrial applications that you can also see here. And I think of advantage is that we are working with these industrial partners as project partners together with some pros and cons, some challenges as well. Yeah. As case studies, but I think it's really important to test all the developed methodologies somehow in real life and with real data. You're mentioning the data gaps. Yeah, that's of course relevant for all such projects. So here you see the sectors and the product studies of the companies you have seen in the pictures before. This protective packaging from Grown Bio. We have selected some very advanced products, but also low TRL level products, like for example building panels that we are assessing. Then two larger companies, Lenzing from Austria and Stora Enso, also like in the middle range of TRL levels. With this company, we have some challenges as they are redesigning the company, so that's a little bit on hold at the moment. And we work with Unilin that are producing chipboard materials. So I think, yeah, that's all. That's the project overview, what we are doing. I hope that gave you an idea what we are doing in the project. And now Christian will present you more in detail, more from the scientific part as well, how we address the circularity aspect in our project. Of course, if you are more interested in all the other topics, then we can arrange dedicated meetings as well with the relevant partners also. That's it.
Thank you, Dominic, for the presentation. Very clear. It is clear that we have lots of common grounds, and I hope we can continue to collaborate in the near future. So continue with the collaborative exchange. Christian Perez from Ghent University will share now insights on the development of the circularity assessment methodology for high-TRL bio-based product systems. Christian is a doctoral researcher at Ghent University, focusing on the intersection of circular economy and bioeconomy. His research explores how circularity assessment indicators can be applied into the bio-based product system. And he also aims to connect methodological innovation with real-world decision-making for a circular future. So Christian, whenever you want.
Thank you. Good morning, everyone. It's a pleasure to be here. Thanks for the invite. And also thanks, Dominic, for the nice presentation, out of which now I would like to zoom in a little bit to show you some of the efforts that we are carrying out in the ESCIB project in relation to the development of circularity assessment methodologies. So to begin with, we seem to have a common problem in the field of circularity assessment, which is a sort of newborn in the family of sustainability assessment methodologies, which is that we, despite, let's say, the popularity that it is gaining, the traction in policy, industry, academia, that it's showing, we all happen to agree that there is a positive impact of circularity. However, the problem is that we cannot agree upon a definition of what constitutes as circular. So there are many definitions out there from different perspectives, aiming at different objectives as well. And we haven't happened to agree upon one common ground for this. And this, of course, hinders the development of circularity assessment methodologies, indicators, and furthermore, the development of circular economy in general, right? So some of the gaps that we consider most relevant are the connections of the circular economy with the sustainability dimensions. And also, we need to further develop a common ground on what should be actually measured to provide a comprehensive overview of a circular performance, and how should that be measured, and to what scope and what regard, right? So in ESCIB, what we've done to address these efforts is, first of all, carrying out a literature review and exploring what is out there. And we have come across many indicators. In our review, we have retrieved about 86 circularity assessment instruments, which encompasses indicators understood as single metrics intended to provide a single score to circularity, but then some sets of indicators that are, as redundantly said, sets of individual metrics or indicators that aim to address multiple aspects of circularity in a single framework. And then we have also seen some tools which are digital-based sets or indicators aimed again at providing a comprehensive overview of circularity. So from this review of the 86 indicators, we have, of course, defined a list of key criteria that needed to be addressed for the evaluation of indicators. And we have come up with 6 different criteria we have assessed, which are namely the flow perspective, understood as the relation of stocks and flows taking place within the life cycle of the product and to what extent it is being taken place. So for example, we can see some indicators focusing on the inputs to the product system. We can see some other indicators such as those that Hasler was mentioning in the last part of his presentation, focusing on, for example, nutrient recovery, and those present a more outflow related perspective. Some others intend to assess only the loops taking place within the system, for example, recycled content indicator, mentioning one of the simplest ones. And some others intend to provide a more holistic perspective, which is, for example, the MCI, which is probably the most popular one in the field of circularity assessment. And if you're in circularity assessment, you for sure know at least this one, right? Then the second characteristics that we have assessed is the type of properties of flows and stocks. So are we measuring only mass-based parameters? Are we addressing also value, for example, via economic value? Is it something else being addressed to provide a circularity assessment? That's what we wanted to understand as well. Then the third characteristic was the way that these flows and stocks that are being measured for the circularity assessment relate to the so-called circular resource management actions. There is a list that was provided by the ISO in the last standard that was developed on circularity last year, and referred to mostly, but not exclusively, technical cycles. So circularity only related to technical cycles, recycling, refurbishing, and so on. Then, conversely, we also want to understand to what extent the flows and stocks are addressed, but instead of technical cycles, in relation to the biological cycles. I mean, we are talking about bio-based products, so it's rather clear, right? Then the fifth key characteristic that we have assessed is the coverage of sustainability. So as I said in the beginning of the presentation, it's not fully clear to what extent should these sustainability dimensions be addressed to provide a comprehensive circularity assessment. So is circularity just a side? Is this complementary? We all agree that circularity is intended to provide sustainability, but we don't know by what means, let's say, this is going to be measured, right? So this is one of the things that we have also addressed. And then finally, we wanted to understand beyond this more scientific considerations, we also wanted to understand how implementable those indicators are. I mean, we can provide a scientifically robust and very extensive indicator, but if it's not applicable in practice, what are we doing our things for, right? So that's also something that we wanted to address in this review. I cannot go, of course, over all the results that we have in this review. There is also a publication coming, but today I would like to share with you some of the results that we obtained in relation to the assessment of flows and stocks in relation to biological cycles. Similarly to what the colleagues of the TEMA were presenting before, we noticed a similar trend when it comes to addressing technicals and biological cycles when it comes to measuring circularity. So there are many indicators out there that are technically applicable to bio-based products. That doesn't mean that those indicators actually address the nature of bio-based resources. And that's what we saw in our review as well. So actually, only 23 out of 86 indicators were explicitly addressing both nature, so the technical and biological cycles. On the other hand, and we actually refer to those indicators as bio-inclusive, which is typically the preferred approach, and it can also, for example, be seen in the material circularity indicator. Then, conversely, we have seen some indicators that are so-called bio-exclusive, that meaning that they only address the biological side of the life cycle, excluding completely all the technical cycles, which again, it's of course relevant for certain types of products such as fertilizers. But if we want to provide a comprehensive and holistic overview of the circularity, this is neglecting one of the most important parts of circularity, which is the technical cycles as well. And the other way around, we have those so-called generic indicators, which were the majority, that were only addressing technical cycles. And again, they may still be applicable to bio-based products, but we don't intend to make use of indicators that only address the technical side of things. So that's pretty much the conclusion that we withdraw from this analysis. And when it comes to addressing the bio-based nature of resources, we came to find that the two aspects were addressed in a very diverse set of approaches. One of them is renewability. So it's clear that we intend to make use of renewable resources, and some indicators literally address that. But there is not a clear way to define what constitutes as renewable. So we have come across some indicators that considered that renewability was important, but so there was an implicit recognition of that without providing an actual definition. So this is not very helpful when it comes to providing a robust and comprehensive assessment. And then we have also seen some indicators simply assuming that bio-based resources are renewable, which again doesn't have to be the case. There are, for example, lignin-based asphalts that are not going to undergo the biological cycle anymore, probably, and this is something that is perfectly fine and happening in technical cycles as well. We have seen some other indicators addressing regeneration rates, so mostly adding an amount of years that are needed to regenerate a resource for that to be accounted for as renewable. But that also can pose some issues when it comes to addressing certain types of biomass. So, for example, growing hemp doesn't take as much as growing wood. Does that mean that hemp is less renewable? Excuse me, that wood biomass is less renewable? Not really, right? Because there are other practices associated to it. So in the end, there are many ways to address this. And the last approach that we happen to find, and which is the one that, if I remember well, is the one that is being used by the colleagues in BioRadar, is the inclusion of certification schemes. So in the end, having to meet a certification scheme to consider that a biomass is renewable, which is very nice because indeed you are somehow safeguarding that the certain negative impacts are being prevented from happening. But at the same time, for SMEs, and this is the case for us as we work with them, this can pose some problems. Some companies don't have the means to provide and to pay for a certification scheme just to simply address that their biomass is renewable. So this is a challenging topic, and this could be a whole presentation. But indeed, there are many ways to address this, and we need to take into account that this is something of utmost importance in the upcoming developments of circularity assessment indicators. And similarly, for the return to the biosphere, so the closure of the biological cycles, indeed, as similarly to the renewability aspect, some indicators simply provide an implicit recognition of this as important, yeah, but not a real definition. Some others simply assume that all bio-based resources would return to the biosphere, which, as I said, doesn't always have to be the case. And some others provide an actual assessment of the biodegradation, nutrient recovery. For example, those indicators typically aimed at addressing, as I was mentioning, fertilizers. But this is mostly linked to the outflow perspective and is not fully embedded in holistic frameworks at this stage. So this is an overview of the insights that we got from this, which is really important, that, of course, is going to tailor the upcoming developments that we are going to carry out in ESCIB. So as an outcome of our literature review, we wanted to eventually build a methodology that would integrate both technical and biological cycles for the reasons that I have been mentioning before. So following a bio-inclusive approach, we want to encompass the most holistic as possible flow perspective, of course, having to deal as well with the uncertainty of data and what we have available out there, especially for our industrial partners. And then Certainly, we want to be in line with sustainability principles, that's clear, but we don't want to overlap or step on it too much. We are trying to consider circularity as something else that has its own characteristics and therefore should be in line with sustainability, but not capturing it to the full extent because we have other methodologies for that. So as a result, we have proposed a framework of 6 indicators in this project that constitute what we have defined as the circularity assessment methodology. So the idea was to provide a number of indicators that would provide some granularity to showcase the different nuances and dimensions of circularity, but not extending too much so that this is closely to other sustainability assessment methodologies and their approach. So I would like to mention briefly what those indicators are about. And the first one, circular inputs, aims to address how circular, being redundant a bit, are the inputs coming to the product system. So, and of course, we need to define a set of criteria to be met for considering a resource as circular. So it can be renewable and, of course, meeting certain sourcing characteristics. But it can also be, for example, metals. Metals that are secondary and come from other industries are undergoing resource recovery strategies and technical cycles can also account to circular. So that's something that we want to address to, again, encompass both technical and biological dimensions into the picture. And the same applies to the circular outputs indicator, actually. We want to understand for those flows derived from the end-of-use product that are leaving the system, which of them are undergoing or which fraction of the product is undergoing a circular route. And for that, we, of course, have to define a set of criteria. Then for the next 2 indicators, we wanted to address the cascading aspects. So we have proposed these 2 indicators, cascading performance of inputs and cascading performance of outputs, to showcase that we are not only caring about the circular nature of things, but also the value that they are providing to the whole system. So for the cascading performance of inputs indicator, we want to understand if those inputs coming from outside of our system boundaries are being downcycled, or being upcycled, or are being given a similar value. And through some scoring, we would be able to somehow benchmark those aspects. And similarly for the cascading performance of outputs, as we intend to understand where are the resources that derive from the end-of-use product going, and whether they're going to carry out a new function that provides higher value, lower, or similar value than it was providing in the previous life cycle. The 5th indicator is value retention. And in this one, we are trying to address something that I haven't mentioned so far, which is stocks. We tend to think of circularity as things moving all the time, but in fact, value retention is really important as well, and is one of the core principles of the circular economy, right? So we also want to address, following similar approaches in the MCI, whether the products that we are studying are providing a function of what kind and for how long. And this is really relevant. So this is going to be addressing this indicator. And finally, with the R strategy performance indicator, we want to outline there are many different resource recovery strategies may happen for the same type of product, material, or component. And we want to understand the size of the loops that are being followed. So you may agree with me that refurbishing a product is not as intensive, or is typically not as intensive as a full recycling of a product. So we, as in mathematics, we tend to say that some infinites are bigger than others. In the circular economy, we happen to think that some loops are bigger than others. And this needs to be accounted for as well. So this is what we intend to address with this one. And for that, in ESCIB, we have also developed an internal tool that is called the Circular Bioeconomy Systems Diagram, which is aimed at indicator development. So what we aimed with this figure was to showcase all the potential and relevant flows that are taking place within the life cycle of the product across different regions. So the biosphere, the main product value chain, the end-of-use management, other secondary value chains, and the different resource recovery stages that may be undergone. And what we wanted to do is to represent those flows in a systematic manner so that those indicators could also be understood from that perspective. And in this figure, what you can see is a representation of the R strategy performance indicator and the flows that we deemed relevant to calculate this one. So that was all about, let's say, the foundations of the methodological approach that we are building. Now, how can this be implemented in practice? What we are doing in ESCIB is, of course, trying to follow something that is already, let's say, somehow developed. And for that, we are taking over some of the core principles of life cycle assessment to also build something, and again, not reinventing the wheel, to build something that is somehow closer to what is out there, to is, of course, the applicability in the end. So we are using a life cycle inventory modeling approach, as can be done in circularity assessment. And this can be fed to our circularity assessment tool, in which certain things that don't typically happen in life cycle assessment have to be done, such as structuring the exchanges, resolving mass balances, which is something very clear for us that are have this engineering mindset, but it doesn't always happen in life cycle assessment, unfortunately. And we also have to demand for certain characterization factors for the inputs and also other flows relevant to the product system. So once we have that model and we have added what is necessary to undergo a circularity assessment, we have to, of course, to calculate those indicators that I was mentioning before. And for that, we are using a tool, and we are following, well, a methodology that is maybe easier to understand for you if you have worked in a life cycle assessment. I will be a bit redundant with this, but typically life cycle assessment, there are many calculations that are taking place. But if we summarize it, in the end, it's sums, subtractions, and multiplications of matrices. And in the end, we are trying to follow a similar approach by, instead of using characterization factors, which is something typical in LCA, we are trying to characterize our inventory via circularity coefficients, which in the end, similarly to characterization factors, it's going to be matrices that provide an insight about the flows that we are addressing. And as a result, and undergoing the same calculations that can be done in other methodologies, we would happen to obtain a set of indicators with results on the different dimensions that we were considering for circularity. So that's more or less the approach that we're following. And then this was all about high-TRL indicators. High-TRL products and indicators tailored to those type of products. But then in ESCIB, we are doing also something else, which is providing a circularity assessment methodology with this perspective, aiming to adapt those indicators that I was mentioning to low-TRL applications. And of course, to deal with this, there are many challenges that we have to overcome, such as understanding how the world and the technologies that are going to be used are going to look like. So especially scaling up the product system, and also understanding, besides the technology per se, how the world is going to look like. We don't know how the energy mix is going to be. We don't know whether certain geopolitical factors may have impacts on the development of certain technologies. So, for example, making use of the IPCC shared socioeconomic pathways, we also want to explore how certain potential futures would affect the circularity of the products that are in our scope. So to sum up, I think one of the key takeaways of our work in ESCIB is that we aim to tear down the tower of Babel of circularity, and we want to provide something that is more structured and granular to showcase that circularity has many sides, and it's not just about a single score or just about something that is not meaningful. There is a lot of work to do here. For that, we want to also foster this bio-inclusive approach. So we are working with bio-based products, which doesn't mean that we only have to look at the biological side of things. There are many technical cycles that are relevant for our products and need to be addressed. And then for that, of course, we are providing circularity assessment methodologies for both high and low TRL products that aim to showcase, as I was mentioning, this granularity of circularity. And that was all from my side. Thanks a lot for listening, and I'll be happy if you have any questions.
Thank you, Christian. Thank you for the presentation. And as you said, there's still a lot of work to be done in the circularity metrics. and what you have presented today, the methodology covering the technical and the biological aspects, also the high-TRL and low-TRL adapted, is definitely a step forward in this sense. So thank you. Thank you for presenting your work. And now we're reaching the end of today's webinar. Before we close up, just a few notes. The recordings and the presentations will be shared with the participants after the event. And the next BioRadar webinar will happen in November 11th from 10 to 12, where another of our project partners will be presenting their implementation scorecard for businesses. You will receive more information about this in our social media and website, so stay tuned for that information. And nothing else. On behalf of the BioRadar Consortium, I would like to thank you. Thank you, the people that are here, the speakers for joining us today, for taking the time, our partners and the ESCIB Project for joining us as well. And this concludes the Bio-Based Transition Indicators Framework webinar. Thank you all for being here and have a great day.
Thanks, Maria, and thank you all.
Thank you.
Thank you.
Thank you.
Bye.
Bye.
Goodbye.
Bye.
Thank you, Beniten.